Hello.
Hi,
Yes, how are you, Clementine?
good and you?
Is your friend attending or she's not?
I don't know.
All right, so let me explain the solutions which I forwarded yesterday on the group because I did not send the recording, remember?
Hmm.
So that when you're writing, you know what you are writing about, or when you're preparing for exams, or you need the explanation. So the question which I was doing yesterday, which I forwarded, was question number 4 for assignment. So number 1, I forwarded to the group. Number 2, I already forwarded question 2. Question 3, I skipped this one. Question 3, I said it's a bit long. We need time.
Mm.
So yesterday, I just forwarded the question 4. I did not forward the video recordings. So I'll be explaining question 4. So which means we are only left with 5 and 6. Then the assignment will be done, and also 3. So let's analyze the question, which is question number 4. So it's saying a string of length L. The string of length L is displaced. On that question which we did yesterday, it was number 5, isn't it? Not 4. Just a correction there. It was number 5. It was number 5, not 4. So I've provided solution for 1, number 2, and number 5. The ones that I still have to forward you, it's number 3, and then we'll do 4 and 6, then we are done. These are the only ones which are left. So for 5, it's this one, which we are doing now, which I forwarded to the group. So a string of length 1 meter is a fundamental node frequency of 5 hertz. If this string is plugged transversely and touched at a point in the center, what are the frequencies? What frequencies persist? That was the question. So you must know the key definition of a transverse wave. This is whereby the wave is traveling perpendicularly to the direction of displacement, which means if the displacement is going upwards, when you plug the string upwards, which means the wave is moving in this direction. So which means they are perpendicular. It's not a longitudinal wave where it is moving in the same direction as propagation. So for a transverse, it moves perpendicularly towards the propagation. So we are plugging the string upwards, and then the wave, when it vibrates, it's perpendicularly to the direction of displacement. That's what you must know about transverse. So when I gave you that solution, it's saying when a string is plugged, then touched at its center, which means our displacement is like this. When you are drawing the knot, something with if it's a sketch, which means when you plug that string, your displacement is going upwards. Here at the center, you plug it, your displacement is upwards. Then when the string vibrates, it's a sine wave vibrating to and forth, to and forth. But the displacement is perpendicularly to the direction of propagation. The displacement is going upwards and the wave is traveling towards the positive x. So here they are saying now certain modes of vibration are suppressed. Okay, these modes are those that have antinode, which is where there is a maximum displacement at the center. So which means these nodes, which is at the center, these are the ones which they are referring to that they are suppressed, which means they are going to vanish. So which means here our node will be number 1, node number 2. Here, node number 3, this antinode. This is the point number 3. And then now we have a node there at number 4. So all antinodes, this one is suppressed. This one is suppressed. So which means you are only left with the even ones which are not suppressed, which are the nodes, not the antinodes. So at number 2, it's not suppressed because the displacement is 0. At number 4, it's not suppressed, and so on. So which means we are choosing only even numbers because our wave is going like this. So if we go 2, the wave will be like that. So this point is 2, 3, and then this will be 4, 5, which is an antinode here. Then the next one, it will be 6. 7, it's an antinode, and then the node will be 7. So all antinodes are suppressed from the definition here. So the modes that have a 0 node, what do we mean by 0 mode? Which means the displacement is 0. This position, I have not moved any distance upwards. The displacement is 0 at this point, at a node. I have not moved any point upwards. Unlike here at an antinode, I have moved a certain distance. So at these points where the displacement is 0, at these points, that's where it persists. That's what they are saying. So the modes at the center are allowed to persist only at 0 displacement, which means these are the modes which are at the nodes. So when you're answering this question, you explain like what we did, that they are being suppressed. Then you also mention that the fundamental frequency is given by what formula? Fn is equals to n multiplied by the fundamental frequency. So the frequency at that mode when n is 1, but in our case, we are having n1, which is 5 Hz. That is the fundamental frequency. So to determine the frequency or harmonics, this is the formula that we are using, which I've just mentioned. So the frequencies of the harmonics are integer multiples, meaning n cannot be 0. You mean integer 1, 2, 3, 4, etc. That is the value of n. However, since the nodes, they are being suppressed, the antinodes are being suppressed, these antinodes are being suppressed, we are no longer counting odd numbers, they are out. From the integers, now we are only picking the even numbers. That's what we are doing there. So we'll be picking 2, we pick 4, 6, 8, etc. so that we can calculate the displacement at the center, which are allowed to persist. All right, so if n is equals to 1, we have been told that the fundamental frequency is 5 Hz. That is the fundamental frequency, it's 5 Hz. So, which means one antinode at the center. The first few modes, shapes for the string are fixed, which means n is equals to 1. fundamental mode, one antinode at the center. The second harmonic, you experience it at the second harmonic, which is the node at the center. Third harmonic at the antinode at the center. That's what is happening. Then N4, fourth harmonic, a node at the center. All right. So since the string is touched at the center, modes with antinode at the center will be suppressed. Like what I've been explaining, the nodes which are at the antinodes are being suppressed. This is an antinode, it's being suppressed. This is an antinode, it's being suppressed. So which means we are only considering 2, we ignore 3, we go to 4. 1, we have already ignored it. So we are only considering even numbers. That's why they are saying, and the modes with a node at the center will persist. Therefore, only even harmonics, which means instead of all integers, n equals to 1, 2, 3, 4, 5, 6. Now I'm selecting only even numbers that will persist. So instead of taking 1, I cancel 1. Instead of taking 3, it goes. It's being suppressed. Then I take 4. Instead of taking 5, 5 is being suppressed. Then I take 6, and so on. So that is what the question was requiring. So now we are calculating the frequencies of the persistent harmonics. So which means F2 is not going to be suppressed. This is when N is 2. It's not being suppressed. It's persistent. That's what they mean. If it's not being suppressed, then it's persistent. Remember this, the string was plugged at the center. Yeah, at the center. That's where the string was plugged. So they are saying at antinodes, it's being suppressed at antinode because that's where it has been plugged. So the only harmonics that we will experience only harmonics for n equals to 2, n equals to 4, because these are the nodes, not antinodes. So now we replace in our formula was saying Fn, which means the frequency for that mode is equals to the fundamental frequency is equals to n multiplied by the fundamental frequency. The fundamental frequency was given as 5 Hz. So, which means now the first n which are going to replace, it will be 5 Hz times the 2. Then you get 10 Hz. Instead of going to F3, because F3 is being suppressed, which means fundamental, when n is 3, that mode is being suppressed. So we ignore 3, we go to 4. So this is our 4, which we replaced there. 4 times the fundamental frequency, 20 Hz. Instead of going to F5, you skip 5, now you use F6. 6 times 5 Hz, 30 Hz, and so on. So which...
I have a question.
Yes, ask.
Those ones that are suppressed, they are odd numbers. Is it because they're at the center?
No, it's not because they are. Is it because they are at the center? Yes, because here we said the displacement, they are suppressed. Why? When the string is plugged and then charged at its center, certain modes of vibration are suppressed. So the only modes of vibration which are suppressed are the antinodes. When you plug a string and then you touch the center of that string, which means the only modes that are going to be suppressed are the ones which are going to be at the center, which is the antinodes, like what you are saying.
So basically, they are not vibrated, they're not moving.
Yes.
In other words.
Yes.
Okay. Now I get it.
Okay. So what is left there, it's just to conclude the story, because the second harmonic at a node, these ones are just referring to when we get harmonic number 1. But for here, we have already concluded that we are only going to take even modes, which means N2, we are going to, this one is suppressed. N4, yes, and so on. This is how we are choosing. So since the string is touched at the center, modes with an antinode at the center. Yeah. So the antinode is the one that is going to be suppressed, and the modes with the node will persist. Only the node, which means, what do we mean by the nodes? Are the ones that are going to persist here. So this is a node. This is a node. And so on, because this is a sine wave, it will continue repeating itself. Transverse, we said the direction of propagation is upwards. And the direction the wave is moving, it's perpendicular to the displacement. That's why it's a transverse. They told us from the question. So the direction of the displacement is up when you plug the string upwards. But the wave is traveling to the right. So you make a perpendicular. That's why it's a transverse wave. If it's longitudinal, which means it's moving in the same direction as propagation. So in our case, it was a transverse wave. So when you calculate the frequency, you just calculate the frequency. You indicate that the frequency which are persistent, or the frequencies of persistent harmonics, are starting at n equals to 2. That's why here we are now having F2, F4, F6. If you want to calculate F8, it's up to you, but you are just indicating that this is going in this fashion like that. It's following that formula, where we are only choosing, instead of taking all the integers, now we are only choosing only the even numbers, 2, 4, 6, etc. Any question here?
No.
So the frequencies that persist, which means they are keeping on repeating, or we are going to have frequencies that will never stop. So these are even harmonics. So 5 times 2, 10. 5 times 4, 20. 5 times 6, 30, and so on. These can be represented as Fn is equals to n multiplied by the fundamental frequency, where n is now an even what? Integer. Remember from the definition, n was just an integer. Can you see here? When we use this formula, n is just a what? An integer. But because of the condition that you are holding the string at the center, there are other modes which are being suppressed. So your n, the condition of n has changed. Now your n is an even what? Number, where n is an even integer, not just integer, yes. Because of the situation that some modes are being what? Suppressed. If you are not holding the string, then n will be 1, 2, 3, 4, etc. because you are not holding it at this end, isn't it?
Mm.
You are touching it at this end, yes. So that was because I just forwarded answers without explaining. So you find out it will be difficult now when you are writing. But when someone explains, it will be better. Now you know what to write. Any question here?
So I want to know, when I'm answering that question, do I just start by answering by where I am doing the multiplication, or do I have
No, you don't do that. You don't do, when you're answering in physics, you don't just come with just saying n is gonna, you explain this theoretical part. You start by explaining the theoretical part before you just punch in the values, so that the marking knows why are you just putting, and why did you disregard n equals to 1, n equals to 2. So that information comes from the theoretical part. So this is very important to say when a string is plugged and then touched at its center, certain modes of vibration are suppressed. These modes are those that have an antinode. So the modes that have a zero, that have a node, which is a zero displacement, which means we are referring to these points, which I'm putting now in red, which have a zero displacement. They did not move any distance in the y direction, these points, the nodes. So that's where it persists, the harmonics persist at this point where there is a zero displacement. So we have explained from the theoretical part first, before you just punch in numbers. You can't just punch. Then
but no need to draw that graph. Do I need to draw it?
no, the graph, they know it. This one is just an explanation of nodes and antinodes.
Okay.
The graph was not asked. No, the graph was not. I'm just explaining so that you know which one is the antinode, which one is the node. This one, which is upwards, which we said it's an antinode. And this one is the what? The node. That you know when I'm counting 2, 4, 6, you know which point. And when it's zero displacement, it did not move any distance upwards. It's a zero displacement. So nodes that are suppressed are the ones which are at the center, which are only the antinodes. So this statement is very important. Then from there, you can introduce the formula to say the fundamental frequency is given by what? F1. So that when you are substituting your equations, where you are saying Fn is equals to n multiplied by F1, we want to know what is F1. So you mention that statement that the fundamental frequency, it's F1, is given as 5. Then from there, you introduce formula that if I want the frequency at any mode, which means it will be Fn multiplied by what? The n, which is the integer multiplied by the fundamental mode, fundamental frequency. Yes.
The one that is
Then,
given.
yes. Then when you now explain that since the antinodes are suppressed, then this is the point which you are going to explain here. Then you come here and you explain this one. Since the string is charged at the center, modes with the antinode at the center will be suppressed, and modes with a node at the center will persist. Therefore, only even harmonics will persist. So this statement is very important, this one. And then from now you punch in your numbers. F2, what. So those 2 points are very important, these ones. So this statement, you start with it, and also the formula, it's important. Then we also want to know why did you disregard n equals to 1, n equals to 3? Because of this statement, which says since the string is touched at the center, modes with an antinode at the center will be suppressed, and modes with a node at the center will persist. Therefore, only even harmonics, n equals to 2, n equals to 4, n equals to 6, will persist. Now you put your values. So instead of saying n is just an integer, now on your final answer, you indicate that n is an even what? Integer now. After you've done the calculations, isn't it? Must show that n is an even integer. All right. Any questions here? where you want to ask. Hello?
I don't have a question. Maybe climate is
So you may write this one down because we have already attempted 3 problems, which is number 1, number 2, and this is number 5. That's telling Clementine that tomorrow we'll start with the long derivation. So they need time, and they have a lot of mathematics and integration, which is coming now. So you must revise your maths about integration so that when we are doing that problem, you won't have problems of understanding. So these ones were easy. So then I said, since these ones are taking time, let's just start with the ones which are easy to understand.
Okay.
Yes. So we'll attempt one of the long derivations, either number 3 or number 4.
So this is number 5.
This is number 5. Number 1 and 2, we are done. I sent you already the recordings and the PDFs.
The one
So
that
yesterday,
it was
question 5, this one. This one is question 5, which is asking for the frequencies. What frequencies persist? So question number 6 and number 4, they are a bit long. They have long derivations. So
okay.
you must be ready as well.
So tomorrow we'll do question number?
We can do number 4. There won't be any problem. We can do number 4. Because there are only 3 questions left.
Okay.
Right. Write these things before it piles and adds pressure to your work.
Yeah, I'm gonna write because I haven't started yet. I'll have to start.
So you have to write so that it does not put a lot of pressure. All right. So it was a short question. We may end here and then we'll continue tomorrow.
Okay.
All right.
Is Clement still online?
Yeah.
I'm not sure.
Can I talk to you on your inbox? WhatsApp?
Okay.
Okay. Sharp. Bye, sir.
All right.